Welcome to our talk at this Bridges 2020 conference. This is a talk on joint work of me, Martin Skrotsky, together with Henriette Sophie Lipschütz. I am currently a postdoc at the RIKEN ITHEMS workgroup in Wako, Japan, while Henriette is a doctoral student at Freie Universität Berlin. We're going to talk to you today about vector fields and Paul Klee, a summer school course for gifted high school students. Paul Klee was a painter living in the 19th and 20th century. He was one of the most influential and well-known artists of the Bauhaus movement in Germany, a movement in architecture and design. He taught as a lecturer at the Staatliches Bauhaus in Weimar, Germany, from 1920 until 1931, where he had to migrate to Switzerland given the rise of Nazi dictatorship. Among other writings, he wrote the Pädagogisches Skizzenbuch in 1925. This is remarkable because he uses this book as an explanation of his symbols and his intentions of writing. Thus, given his writing, this enables us to interpret Klee's painting on the foundation of his own explanatory texts. In the Skizzenbuch, he devotes several chapters to arrows and the use of arrows. He characterizes the arrow as the father of thought. How do I extend my reach there? Where to him this place where the arrow is pointing can never actually be reached by a human. He distinguishes in his writings the real and symbolic arrow. On the top of this sketch we see the real arrow, which according to Klee has a shaft, a tip and fletching. In the lower part of the sketch he depicts the symbolic arrow, which is a track, a tip, and a fletching integrated into it as tip fletching. In his paintings, Klee uses arrows frequently. On the left-hand side, we see the painting Betroffener Ort, affected place, where a large arrow is pointing downwards on the actual symbols in the painting. The right-hand side painting, Schwankendes Gleichgewicht, wavering balance, shows a multitude of arrows pointing in all directions, arrows of different width and length, some of them curved, some straight. Arrows also play a huge part in mathematics. On the left-hand side we see them as directions in a diagram that includes the derivatives of the trigonometric functions. On the right-hand side, we see a discrete vector field on a hand geometry. This vector field was generously provided by Konstantin Pölke.
The course Vector Fields and Paul Klee was designed for summer school of the Deutsche Schülerakademie, German People Academy, or for short DSA. The DSA is a non-profit association founded in 1988 and focuses on the promotion of gifted high school students. Therefore, the DSA offers about 7 summer schools per year, which take place in different boarding schools in Germany. Each summer school consists of 6 separate courses from different disciplines such as mathematics, physics, linguistics, and literature. Each course is taught by 2 volunteers with diverse backgrounds. They are selected based on their qualifications and the quality of their project proposals. Each summer school takes 15 days. Except the excursion day, this is the 5th day, every day consists of 4 slots of about 90 minutes, which are spent on the course content or school comprehensive activities. The course we designed for the DSA focused during the first week on establishing the mathematical and artistical framework. Here, the biography of Klee and his understanding of his art were introduced, as well as the connections to mathematics. An important part of every DSA summer school is the writing of a commemorative collection, Dokumentation in German, or Doku for short. All participants of one course create a chapter of the Doku together. They present and recall the newly learned course contents. Therefore, we devoted one slot to introduce the document preparation system LaTeX. The Doku has to be finished within the summer school. After introducing the mathematical basics, the participants developed individual art projects, either haptic or digital. Therefore, we used the so-called gallery method. The participants got 20 minutes and a huge empty sheet of paper to collect ideas and topics they would like to work on. Subsequently, all participants got the opportunity to take a look at all posters and provide feedback to the creators by placing post-its with questions and comments directly on the posters. Thus, the original poster remained untouched. Therefore, the group was split into two groups, one working haptically, the other working digitally. To allow discussions and to satisfy the participants' interests, we reversed some slots as joker slots. Next to the Doku, the so-called rotation is another important part of every DSA summer school. Each course splits into, in our case, 6 groups of 2 or 3 participants. Each group gives a presentation on the contents covered so far. Participants and tutors attend presentations of courses other than their own. Individually and hence the presentations are held from an audience comprised of people. The participants were asked to material have to be given in some other math-related remaining slots are free time. In the scope of the participants and tutors can offer sessions to all members of the summer school, from which they are going. Often they do spot together, play games, or give an introduction to a hobby or language they speak, or continue working on their projects or the Doku. Our course had 16 participants, 10 female and 6 male, aged from 15 to 18. The slots devoted to mathematics mainly consisted of the presentations given by the participants. Therefore, a reading list was sent to them, serving as a basis for the presentations, which were prepared before the summer school. Next to the talks on mathematics, Klee's biography and his sketchbook were introduced. Some participants presented paper from the British community chosen by themselves to emphasize the relation between mathematics and the arts.
The Organization for Economic Cooperation and Development, OECD, defines mathematical literacy as an individual's capacity to identify and understand the role that mathematics plays in the world, to make well-founded judgments, and to use and engage with mathematics in ways that meet the needs of that individual's life as a constructive, concerned, and reflective citizen. For our course, we derive 2 goals from this. On the one hand, participants should be able to build a common basis of mathematical knowledge, and on the other hand, should be able to present it to possibly less knowledgeable peers and family. We achieve these goals via presentations that the participants gave in the context of the course and the completion of their own artistic project, which serves as a means of communicating their ideas and the underlying mathematics. We would like to point out 3 positive take-home messages from the experiences that we made during the run of our course. First, the participants each had a green, a yellow, and a red card in front of them. Frequently during the course, we, as course leaders, or the participants themselves when giving their talks, would ask for a quick, non-verbal feedback from the entire audience. By showing the respective card, green as in I understood everything, yellow as in some points are unclear to me, or red, I'm completely lost, it was easy to get a quick visual idea of whether the audience is following the talk. Second, we employed the gallery method in order to give participants an idea to structure their own artistic project. In the gallery method, which is described to larger detail in our paper, participants write on a big sheet of paper all their ideas about their artistic project. The sheets of paper are then arranged in a gallery, and all participants, as well as us as teachers of the course, are invited to walk along the gallery and to put little post-it notes with comments, suggestions, or questions onto the different sheets of paper. Every participant is free to accept or reject any suggestions made to his or her own artistic project. Finally, we decided early on to split the group into two different halves. One half doing a hands-on haptic project, which was provided canvas and paint. The other half was provided several laptops and corresponding programming languages in order to perform a digital artwork project. This suited our participants really well, and about half of the course went into each of these groups.
In total, the concept of the course, vector fields and Paul Klee, worked out very well. For a rerun, we would go for a math and art-related topic again, but choose a different artist. For instance, Escher combined with the tilings of the hyperbolic plane, or tessellations in general, since the level of abstraction of mathematics in Klee's art is comparably high. Since the participants struggled severely with giving their presentations, we would urge to include more detailed guiding questions and let them solve more exercises. The concept of a DSA summer school does not include any performance review in terms of grades on purpose, which directly contributed to a relaxed course atmosphere. Therefore, we cannot make any statements on the gain of knowledge induced by the course. The participants chose individually an appropriate medium to realize their projects. The participants were asked to include Paul Klee's philosophy or some other math-related topic into their project. Within the scope of the docu mentioned earlier, the participants wrote artist statements from which we are going to read some outtakes. And now to the artworks.
Albert Kniazew, ohne Titel. The aim of the project is to depict the unattainability of heaven, respectively of perfection of man. The work is inspired on the one hand by a talk on the Pädagogisches Skizzenbuch by Paul Klee, which defines the arrow as symbol for the mentioned motive, and by fractals on the other hand. Above the vanishing point a being arises, which is inspired by the painting Cosmic Christ by Alex Gray. Together with the being, this symbolizes on the one hand heaven, and on the other hand a kind of epiphany. In the opposite corner, an empty human is reaching greedily, respectively longingly, in direction of the vanishing point.
Angeli George, unregelmäßige Harmonie. Time of the Bauhaus, 1990 to 1933, the aspect of harmony was an important part of art. The chessboard pattern is a typical example of regular distribution of elements as described in Paul Klee's theory of form. Since the irregularity of the chessboard pattern appears to be too easy, it was a challenge to create a pattern which is irregular but also balanced at the same time. The picture presents irregular distributions of rectangles which fill out a square. All sides of the rectangles are pairwise collinear, parallel, or orthogonal.
Anna Dorna, Ephemeros 1 bis 4. The series picks up several mathematical notions, such as vectors, vector fields, curl, divergence, and norms. This is accentuated through the recurring use of arrows, as they can also be found in Paul Klee's paintings. Because of the high number of geometric forms, the paintings appear to be constructed and abstract. As in Klee's paintings, the arrows create energy and point to a goal human beings are longing for. Still, humans will never reach it. This is intensified by rotating arrows as well as by the divergence-free vector field. Everything is turning in a circle, no end is in sight. In contrast, the colorful and bright colors arouse positive feelings in the observer.
Birgit Zickler, Flug der Pfeile, Serie in Blau, Grün und Gelb. The series is based on the idea of combining vector fields and color gradients. Color gradients are suitable for this, since the transitions between light and dark colors can be depict directions of movement. The next step consisted in the development of different color gradients, which lie behind the vector field homogeneously. The effect to be reached consists of adding a depth effect to the two-dimensional vector field and of representing it spatially. The used colors were best suitable for the effect to be evoked. Pastel was chosen because it is well suited to produce homogeneous color gradients. Especially the transitions between different colors can be drawn easily.
Lara Tolmin, Konstruktion eines Doms. The idea behind the project is to use an iteration of the Koch snowflake curve as floor plan of a building. Vectors and gradients should be included in the creation of round windows and pointed arches typical for the Gothic style. Giri tilings are used to create windows typical for churches. The project is realized in a manual, architectural sketch of the building. On one hand, the fractal forms represent the apse of the church. On the other hand, they represent two towers on the left and right-hand side of the main entrance. The remaining floor plan corresponds to the representation of a typical nave.
Besser schön bauen, Vektoren verschieben Farben. The first and the third painting shall illustrate the notion of divergence of a fictive vector field. In the first image, this is supported by the colors, which are arranged in a circle and become darker and darker towards the outside. In the third image, the colors become darker towards the center. The color shades are sustained through solitary vectors. On the left-hand side of the second painting, the blue tones of the first painting occur. On the right-hand side, the red tones of the third painting occur. This represents Paul Klee's thoughts on the balance of warm and cold colors.
Samantha Weiden, Beton 4. The painting represents the facade of an apartment block in a slightly reduced form. The building was constructed using parallel perspective, which is also used to represent three-dimensional objects in coordinate systems. The connection to mathematics is in the precise way of working and in the representation of structure. The project also picks up on Klee's theory of uniform weight distribution through the regular composition of light and dark surfaces.
Niklas Steger, Rotation 1 und 2. The background is designed with a color gradient in which each individual color is equally weighted. According to Klee's philosophy, every color should be equally distributed. In addition, the used colors reflect the visual range of humans and are also arranged according to their corresponding wavelength. The left image represents the simplified version of the rotation within a vector space. The second image has the same gradient. Furthermore, both images can be arranged next to each other independently of the side, as long as red is on top or bottom, as neither the symmetry nor the gradient is destroyed by this rotation.
Niklas Steger, Fibonacci-Folge. The picture was painted on square paper with a side length of 21 centimeters. In the middle is a square with a side length of 13 centimeters, which is composed of other squares with a side length of 1 centimeter, 2 centimeters, 3 centimeters, 5 centimeters, or 8 centimeters. It is also easy to see that all side lengths of all squares are composed of the Fibonacci sequence. In addition, the square, which is 13 centimeters times 13 centimeters, contains 34 squares, where the number 34 is also a member of the Fibonacci sequence.
Isabel Can, noch kein Titel. The project, no title yet, is an interpretation of the Pythagoras tree, which is a form of a fractal. The background is black and the Pythagoras tree is gray and white. The design was chosen to emphasize Pythagoras' characteristic triangle with dark areas, as these stand out next to the light squares. The connection between art and mathematics is strengthened by the artistic abstract design of the tree on the one hand and the emphasis of mathematics on the other.
Charlotte Ahrens and Annika Seidel. Es dreht sich. First, a discrete scalar field was created. In the source code, the function equation can be changed at will to create different functions. In the figure, the equation x1 and x2 go to x1 squared plus x2 squared plus sine of x1 plus sine of x2 is graphically displayed. To create the color gradient, the average height of each element of the discrete scalar field was calculated. This height was then assigned a color value consisting of blue, green, and red parameters.
Laura Blechschmidt, Elias Dinche, Raphael Mergehen, Lukas Schicht, Martin Wiederny. Surrender. The finished animation shows our planet in the center, which is regularly orbited by its satellite. In the background a vector field is shown, which adapts to the circular orbit. The vector arrows show the strength and direction of the added gravitational field of the two celestial bodies. When looking at the animation more closely, it can be seen that the weight forces balance each other at some points. In addition, it can be seen that the gravitational field of the Earth is stronger than that of the Moon. The reason for this is that the mass of the planet is the greater, which is why it is also shown larger.
Thank you for the interest in our work. We hope you enjoyed the different interpretations of mathematical art created in the verge of our course. To read the full paper, you can visit the link shown on this slide. We would like to thank in particular all of the participants for letting us show their work and for their hard work during the course. Furthermore, we extend our thanks to Dr. Pölke for letting us use his hand and for www.bandsound.com for letting us use the music. You can find all artworks in higher resolution and a translated complete artist statement of each participant at the website shown here. If you have any questions, please feel free to contact us at the shown mailing address or find me on Twitter. Thank you so much for your interest.